now how do we find the LCD, the least common denominator. In order to find the LCD, we follow the same process that we follow to find the least common multiple of two numbers. Well, I'm going to show you several examples for this problem since it seems that we have different cases, some simpler and some more complicated. The easiest way to find the least, meaning the smallest, common, the same multiple of two numbers is take the numbers and write all their multiples 3, 6, 9, 12, 16, 15 and so on. 4, 8, 12, 16 and so on. Then, after you find enough different multiples of the two numbers, take now the number, okay, and find what is the common one. Right here, as you can see, the common multiple is the number 12. Okay, it's clear. So what does this mean? This is the smallest common multiple of 3,6, 4. So this means that the LCD of 3 and 4 is the number 12. In this case, it's really easy to find because they are relative primes. 3, 4 are relative primes. They have nothing in common. So this means that you can immediately see that their least common multiple, it will be nothing else than their product. So the least common multiple will be nothing else than 3 times 4. Okay, that is 12. Let's take now the numbers 5 and 12. Okay, I will do exactly the same process that I did for the top numbers. 5, the next multiple is 12, the next number is 15, multiple is 15, the next one is 20, and so on. I do the same for the number 15, 15, 30, and so on. Okay, so what does this mean? What do I have right here? Well, what I have right here is something even simpler. The number 15 appears to be a multiple of number 5. So do I need to do anything else? No, this is simple. As you can see, I can just get the LCD of 5 and 15 to be nothing else than 15. Okay, remember that if you have two numbers and the one is a multiple of the other, then the LCD, the least common multiple, not LCD, the least common, the LCM of the two is number 15. Okay, there's nothing else than the multiple. Okay, but what exactly happens when you have two numbers that the one is not a multiple of each other and they are not relative primes? They have something in common. Okay, let me show you here the steps that you have to follow. You take the number 9 and you rewrite it as a prime factorization, 3 times 3. You take the number 15 and you rewrite it as a prime factorization, that is 3 times 5. The least common multiple of those will be nothing else than the product of the digits that you see in the least common, in the prime factorization of those, so the 3 and the 5, multiplied this many times by themselves, as many times as they maximum appear in one of the prime factorizations. So, look at the 15. You have 1, 3 and 1, 5. Look at the 9. You have 2 3s and 0 5s. So what is the maximum? What is the maximum number of 5s that appears in one of those? 1. The 5 appears only once on the second one. What is the maximum number of 3s that appears on one of these factorizations, on the 9 and on the 15? Well, the maximum number is 2 times. Why 2? Because it appears 2 times on the 9 and once on the 15, which is the maximum. You don't add them, you find what is the maximum, and it's 2. So there are 2 3s here. These many 3s will appear in the LCM. So the LCM will be nothing else than 9 times 5. That is equal to 45. This will be the LCM for 9 and 15, the number 45.